What if I told you that Google DeepMind has just launched 2 AI models that could completely revolutionize robotics? Meet Gemini Robotics and Gemini Robotics ER, systems designed to give robots something that looks a lot like instincts. These models can see the world, understand commands, and take action intelligently, without the need for manual programming for every new task. Sounds like science fiction? Well, it's already happening. In today's video, we'll break down why these models are a massive leap for automation, how they outperform everything we've seen before, and what this means for the future of robotics. If you're passionate about AI and technology, make sure to like this video and subscribe to Uncomplicated AI for more insights. Gemini Robotics, AI that sees, understands, and acts. On March 12, 2025, Carolina Parada from Google DeepMind introduced Gemini Robotics, an advanced vision language action VAA model built on Gemini 2.0, designed to directly control robots. What makes this so groundbreaking? Gemini 2.0 was already recognized for its multimodal reasoning. It could read text, interpret images, and process audio and video better than any previous AI model. It could analyze complex datasets, understand context across different formats, and even generate code with high accuracy. However, until now, its capabilities were mostly limited to digital interactions. It could describe an image, summarize a video, or answer questions about a dataset, but it couldn't physically interact with the real world in a meaningful way. With Gemini Robotics, we now have a system that doesn't just generate text, images, or code. It produces real-world physical actions that robots can execute instantly. This means robots powered by Gemini can move, manipulate objects, and respond to their environment without needing pre-programmed instructions for every scenario. Whether it's picking up a tool, assembling parts, or even carefully handling delicate objects, Gemini Robotics adapts dynamically based on what it perceives. Unlike traditional robotic systems that rely on predefined motion paths and rigid task execution, this model continuously analyzes its surroundings, understands the best course of action, and adjusts in real time to handle unexpected situations. But that's not all. Google DeepMind also introduced Gemini Robotics ER, where ER stands for embodied reasoning. This model brings an entirely new dimension of spatial intelligence to robotics. Instead of merely reacting to commands, Gemini Robotics ER gives robots an advanced spatial understanding, allowing them to analyze objects in 3D, predict their movements, and determine the best way to grasp them based on their shape, texture, and weight. This isn't just about recognizing objects, it's about truly understanding how those objects exist in the physical world. For example, if a robot needs to pick up a cup filled with liquid, Gemini Robotics ER can calculate the best grip point to avoid spills, determine the safest movement trajectory, and even adjust its grasp based on real-time sensor feedback. If an object is fragile or slippery, the model can modulate its grip strength accordingly, ensuring delicate handling without damaging the item. Even more impressively, Gemini Robotics ER can plan complex movement paths in real time. Imagine a robotic arm in a cluttered environment, needing to retrieve a screwdriver from a toolbox filled with other tools. Instead of blindly reaching for it and knocking things over, Gemini Robotics ER maps out a precise collision-free path, taking into account obstacles, spatial constraints, and potential changes in the environment. If something shifts unexpectedly, like another object falling into its path, the model recalculates instantly and adjusts its motion on the fly. This represents a massive leap forward in robotics, enabling machines to operate in messy, unpredictable real-world environments with a level of reasoning and adaptability far beyond what we've seen before. A new era for intelligent robotics. In the past, robots needed to be manually programmed for every new action, requiring engineers to carefully define each movement, grip strength, and sequence of operations. This made automation rigid and inflexible. If conditions changed even slightly, the robot would either fail the task or require time-consuming reprogramming. But now, with Gemini Robotics, that limitation is gone. Instead of relying on predefined scripts, robots can understand natural language commands, assess the situation, plan the movement, and execute it, all in real time. This means you can simply tell a robot what to do, and it will figure out how to get the job done on its own. Imagine asking it to fold an intricate origami figure or pack a snack into a Ziploc bag, even if it has never been explicitly trained on that exact task. Gemini Robotics can infer the correct sequence of actions, adjust its grip for delicate folds, and execute precise movements. This is possible because the model is built on top of Gemini 2.0's advanced multimodal reasoning, allowing it to process visual, linguistic, and spatial information simultaneously. But what truly sets it apart is its ability to generalize across tasks. In rigorous benchmark tests, Gemini Robotics more than doubled the performance of previous state-of-the-art models, demonstrating an unprecedented level of adaptability. Unlike traditional robots, which struggle with new objects, variations in shape, or changes in positioning, Gemini Robotics can learn from context and apply knowledge across different scenarios. And here's the truly impressive part: it can handle unexpected changes in its environment with no human intervention. If an object shifts position, slips from its grasp, or gets knocked over, the robot doesn't freeze or require a manual reset. Instead, Gemini Robotics instantly recalculates its approach, adjusts its grip, and continues the task. This makes it ideal for real-world applications where environments are dynamic and unpredictable, from home assistance and manufacturing to logistics, and even search and rescue operations. Seamless interaction. Talk to your robot like a human. Another major breakthrough with Gemini Robotics is its interactivity. Unlike traditional robots that require strictly predefined commands and complex programming, Gemini Robotics allows you to communicate with it naturally, just like you would with another person. Instead of relying on button presses, coded instructions, or manually setting parameters, you can simply speak to the robot in everyday language, and it will understand, plan, and execute the task accordingly. For example, if you say, "Move those boxes to the shelf, but leave the red one on the floor," the model doesn't just break the sentence into keywords. It fully understands the context and intent of your request. It recognizes that those boxes refers to a specific set, identifies the shelf as the destination, and correctly interprets the exception. Leave the red one on the floor. There's no need for a special programming language, complex syntax, or manual adjustments. It just works. This level of conversational control has massive implications for robotic assistants in homes, workplaces, and industrial environments. It eliminates the steep learning curve traditionally associated with robotics, making these systems more accessible, intuitive, and user-friendly. Whether in factories, hospitals, warehouses, or even personal home assistants, Gemini Robotics opens the door to a future where interacting with robots is as easy as giving verbal instructions, without needing to be an engineer or programmer. Mastering dexterity, the missing piece in robotics. Have you ever noticed how simple tasks for humans, like turning a doorknob, folding a piece of paper, or carefully picking up a fragile object, can be incredibly difficult for robots? While we instinctively adjust our grip strength, movement speed, and angle of approach, traditional robots struggle with these tasks because they lack the fine motor control and adaptability that come naturally to humans. Historically, robotic systems have required precise programming to perform even the simplest manipulations, often failing when faced with slight variations in object shape, weight, or positioning. But Gemini Robotics changes that. Designed to handle fine motor tasks with human-like dexterity, this AI-powered system allows robots to interact with objects in a way that feels natural and fluid rather than stiff and mechanical. Google DeepMind has already showcased footage of robotic arms performing delicate manipulations, such as folding paper, adjusting grip strength in real time, and handling fragile items without breaking them. This represents a huge leap forward in robotics, enabling machines to perform tasks that previously required years of engineering effort to program manually. Now, imagine a robot that can pick up a coffee mug by the handle, positioning its grip at the perfect angle without squeezing too hard or letting it slip. That's exactly what Gemini Robotics ER specializes in: advanced spatial reasoning and motion planning that ensures robots interact with objects safely, efficiently, and with remarkable precision. It doesn't just recognize an object, it understands how to approach it, how to grasp it, and how to move it without causing damage. Whether it's packing fragile items, assembling intricate components, or even assisting in medical procedures, Gemini Robotics ER brings a new level of precision and adaptability to real-world robotics. Google's vision for the future of robotics. Google isn't just developing this technology in isolation. They've already partnered with Aptronic, a company specializing in humanoid robots, including their Apollo model. But Aptronic isn't the only player involved. Companies like Agility Robotics, Boston Dynamics, and Enchanted Tools are also testing Gemini Robotics ER in different robotic systems. This widespread testing will likely accelerate real-world adoption of these models, ensuring safety and ethics in AI-powered robotics. But here's an important question: what about safety? After all, we're talking about robots that can make independent decisions in real-world settings. To address this, Google DeepMind has developed the Asimov dataset, named after the famous 3 laws of robotics by Isaac Asimov. This dataset is designed to test and refine the ethical and safety measures embedded in these models. Google has also introduced a robot constitution, a set of natural language rules programmed into the AI to ensure it avoids unsafe or unethical actions. Beyond that, Google has formed an AI Safety and Responsibility Council that regularly evaluates the social and ethical impact of robotics, consulting external experts to ensure the responsible development of autonomous AI systems. AI that learns on its own. One of the most impressive aspects of Gemini robotics is its demonstration learning capability. If a robot doesn't know how to complete a task, you can simply show it a few times, and it will learn on its own. Additionally, for developers who want more control, the model can generate Python or other programming scripts to fine-tune robotic behaviors, allowing for custom automation and adjustments. Conclusion: the future of robotics is here for years. Robotics has been limited to industrial applications and research labs. But with Gemini robotics, we're now on the verge of having truly intelligent, useful, and adaptable robots in our homes and workplaces. With the ability to see, understand, act, and learn, this technology could mark the beginning of a new era of human-robot collaboration. So what do you think? Would you want a robotic assistant in your daily life? Let me know your thoughts in the comments. If you enjoyed this video, don't forget to like, subscribe to Uncomplicated AI, and hit the notification bell so you never miss an update on the latest AI breakthroughs. See you in the next video.